Hello and welcome back. Today we're going to work with the distance formula in section 1.1. The distance formula is used to find how much distance is between 2 points on a grid coordinate axis. So if you have a map with latitude, longitude, those types of things that have grid coordinates, we can find the distance between those 2 points in a straight line version. The formula is based upon generic values for x and y. So x coordinate and y coordinates are generic, so they use subscripts. This point right here is x1, y1 on the graph, and this point up here is x2, y2. So the distance from here to here is the y distance traveled. So we're going from this y distance, which is y1, up to this y distance, which is y2. So that distance is y2 minus y1. If we travel horizontally, we're starting at x1 here, horizontally, and traveling down to this point, which is x2. So the distance between these 2 points is x2 minus x1. Now the formula is given right here below. The distance is the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, when you're working on the formula, make sure that this part, you do this part first, second this part, add third, and then take the square root last. That's the order of operations here. So we're going to do an example of this. Now, the distance formula is related to the Pythagorean theorem, which is a squared plus b squared equals c squared. So the Pythagorean theorem, a squared plus b squared equals c squared is related to this in that the distance d here is actually c in the formula. So in order to solve this for c, we would take the square root of it. And the distance a and b are the distances of this side of the triangle, these two right sides, right where it's a right angle here. This side is a or b, and this side is the other one, a or b. So as you can see here, this relates to one of the sides, either a or b, and this relates to the other side, a or b, and then c is the d value here, this longest distance. And that's related to the Pythagorean theorem in that we can do it that way as well. So the distance formula and Pythagorean theorem are related. So let's do an example using the distance formula. On the next page I have an example here. We're going to find the distance between the point -2, 3 and the point 10, 8. Now you have to excuse my slowness here. I'm not using a mouse. I actually have the mouse on my laptop, which is a little harder to manage. So we're going to start at -2, 3, which is right here. Let's see, I'm going to draw a line that is a different color. Okay, so -2, 3 is right here, and that line is going to go to 8 or 10, 8. 10 is all the way over, 8 is right here. So we're looking for that distance. This is going to be our d value in the formula. Okay, so when we do that, we're going to have two other distances that we're going to deal with here. We're going to be dealing with a dotted line distance from, let's make these red, from here. So this is our distance this way, horizontally, and then we have a vertical distance going up to there. So that's going to be the two distances that are going to be related. Our x2 minus x1 is going to be this side, and y2 minus y1 is going to be this side of our picture. So using the formula, though, we can just write that out. Let's see, we have d equals, Okay, now we need to label the 2 points that we have here. Let's just label them in order as I see it. So I'm going to put this as x1 and y1. And I'm going to write this as x2 and y2. Okay, so using the formula, we're going to start with our parentheses here. So we're going to put in our x2 first, which is 10. So we have 10 minus our x1, which is -2. Oops, that's we need to make that a little cleaner. This is like I said, this is my first time using this mouse here, so you're going to have to, I'll get better at it as I go. It's like anything else, you get better as you use it. So here's our x2 minus x1 plus our y2, which is 8, minus y1, which is 3, squared, and that's all going to be in the square root. All right, so that's the formula using what we have here. So when we do this subtraction, we're going to get 12 here, squared, and it's going to be 5 squared. So that's going to give us square root of 144 for 12 squared, and 25 for y squared. The y side squared is 25. 5 squared. Now if we add those up, we're going to get the square root of 169, and the square root of 169 is 13. So we're saying that line length up here, we're saying that distance is 13 here. We're saying that this equals 13 units. We don't know what the units are, but we're saying they're 13 units. Okay? So that's what we would do here. And if we look up here at the dotted lines, we count horizontally, we would get 12 for this side. We count horizontally across 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We get 12 units there. If we count vertically, we get 1, 2, 3, 4, 5. Those two values are the values found in the formulas down here. Those are the distances. And we would be able to use our Pythagorean theorem to verify that we got the right answer, because 5 squared plus 12 squared, a squared plus b squared, does equal 13 squared. So we can verify our formula using the Pythagorean theorem and make sure that we have that done correctly. So that is the distance formula. You want to make sure that you write down your formula here and that you practice the order of operations. Make sure that you do the subtractions first, then square, then add, and then take the square root. So that's the order that you want to do that in. So good luck on your homework, and if you have any questions, give me an email.